Um, okay, there's not 2,000 people like in the morning. This is amazing. Those are really big workshops. How do we want to start this? All right. Raise your hand if you know what Rust is. Keep your hand raised if you've installed Rust before. If you have a current version of Rust. All right. If you have Rust Analyzer installed. If you have tried, if you've run at least Hello World. Okay. What about, what's next from Hello World? If you fought a lifetime issue and cried at least twice. Okay. Anyone published a Rust trait? No? Anyone contributed to open source Rust projects? Would anyone say that Rust could be their primary programming language? Okay. You can help me debug other people if they run into problems. I'm serious. No? So, hello everyone. My name is Miguel Guzmán Macedo. I'm Miguel Guzmán Macedo. Someone told me that I speak very fast in Spanish. I work professionally in Rust. I'm going to tell you about that in just a bit. I teach people how to code in Rust professionally. Okay. This workshop is for you if you are fairly confident in your Julia or not that confident at all, and you're curious about Rust and what it can bring you. I will be talking about what I don't think it can bring you, what I do think it can complement. But I will talk about also why learning Rust as a Julia person is usually very, very disappointing. Raise your hand if you found a very enthusiastic Rust person that came up to you and said, let there be light. No. If you had a Rust person come up to you and say, oh, it's fast, it's got a good package manager, it's got a really nice documentation system, no, it's got LVM as a backend, and it's memory safe. And all of us went, yeah, no shit. That's what I expect, right? So not only does most of the marketing and educational materials just cater towards people that don't have any of those boons going for them, it's places where Julia is known to have weak points that Rust tends to shine. Critical safety, embedded software, constrained environments, no? Ultra real-time places. That's not where you really want to be running Julia. I know people here do that. Congrats, you're a JuliaCon, you're a super hacker. But for mortals, it's just going to be a painful experience. Huh? This is to say, if you're a Rust person, you're super proficient, or this workshop is mostly going to go along the lines of, I found a bunch of pain points. I want to save you from some of them. We're going to go through some live coding to see what are some of the cool stuff that Rust offers us, learn some idioms from Rust, and towards the end, talk about the possibilities for FFI and some of the tooling that exists. Huh? This is not we are going to be super hardcore, only look at Rust code. It's going to be mainly look at, oh, if I'm coming from Julia, I would have wanted to know this before I ran into it headfirst. Okay? Does that sound like a reasonable workshop expectation? Hopefully I can save people 3 hours of pain. I'm gunning for, realistically, at least a month of your life will be saved with this workshop, or from reading some of the materials that I point to. Okay? Okay. Now, who has Rust installed? Raise your hand if you have Rust installed, Rust Analyzer installed, and cargo bin installed. Yeah, probably. Can some of the proficient Rust people help? So everyone has cargo bin installed? Yeah? Okay. We're going to be using it later to use some of the dependencies. Oh, cool. So, all right. I've been a Julia person since like 6 or 7 years ago. I think some of the first people that taught me Julia are here in the room. Thank you, Scott. No, I was asking a lot of dumb questions. I met people through the Slack and they said, oh, that's not how you do 2 + 2, dude. And they very kindly answered some of my questions. I was able to pick it up from there. I got my first coding job with Fair Systems. They're a a well-known player in the Rust space. We do a lot of maintenance for open source tooling, and we have our open source educational curriculum all online. So if you want to learn Rust, we have at least slides. There's a lot of other courses. Ask me later, and I'll put up some links about it. I started during the pandemic. It was very boring, and I figured out that I didn't really know what was going to happen in the future, and I was the most annoying Julia fanboy ever. So I figured that diversifying might be a good idea going forward, given that the world was not as predictable as I wanted it to be. I joined First Systems about 2 years ago, and my job is just teach. I have people show up to a Zoom call for 6 half days, and then I go through some of the slides that I'll be showing you. I basically get people that come from JavaScript or Go or Python or C, C++, and I tell them, this is Rust, this is what you can expect, these are the sharp corners you should avoid. I think I tried learning Rust at least 6 times and gave up. I had a lot of help from people that were kind enough to hold my hand and get me to and help me work out issues. Also, I'm part of the Portable Cindy group in the Rust compiler. They have a different social structure to how they organize themselves when it comes to people contributing to the core language. So ask me Cindy questions later if you want. Also, I help review this book, or rather help find the typos in Rust Atomics and Locks by Mara Boss. Mara is one of the standard library lead designers for Rust. They're super cool, super capable. Try and get that book from an independent bookstore if you can. But yeah, that's sort of me. Any questions for me so far? All right. I will be saying a false statement within the next 15 minutes, and I expect someone to catch me on it just to check that you still have a pulse. Okay? Yeah, and I've suffered how not to learn Rust many times. We'll go over, I told you the first stuff about questions. We'll go over a dev flow example. Am I speaking ridiculously fast? I think I am. No, it's just, I'm going really fast, I think. We're going to be talking about good type safety examples that Rust people have encoded into the language and they have names for that I don't see used in Julia. And then lastly, we'll be going through an FFI walkthrough and some tooling. Also, can I get my second in command, please, or someone who is looking at the timer? We all in favor of taking a 5-minute break every hour? Raise your hand. Yes? All right, we'll be doing that. Could someone please remind me just before the 2 minutes, 2 hours and 2:25? Yeah? Perfect. Thank you very much. All right. It is my humble opinion that, let me get on my soapbox. No, it is my humble opinion that one of the biggest barriers for people learning Rust is, at least when they come from the C and C++ background, is pedagogical humility. That's a very fancy way of saying they're not able to accept that they're going to make mistakes and tools can do it better than them. There's a real macho side towards people being like, I don't need a compiler to tell me what to do. I can do malloc and free by myself. Like, I don't need a safety belt. I can drive drunk. I'm good. You crashed, you died, skill issue. Rust people tend to be more along the lines of, no, you shouldn't be able to drive drunk. You shouldn't be able to do that. Those tools should not exist. That's not a thing. We shouldn't allow that in the first place. So one of these is like the way in which they've cultivated safety by default lets them have a lot of benefits that we don't see in Julia, or we see the pains, but we don't have the words for it. For example, the compiler is basically a huge amount of unit tests that get run on your code every single time before it runs. And if they don't all pass, it won't let your code compile. That's what static types let you get, broadly speaking. No? I'm going to give a talk tomorrow about this other project that I worked on. I faced a PhD student who's very capable, but had written 5,000 lines of Julia over 2 years by himself basically in Fortran with Julia on top. It was horrifying. After like a month, we got it down to 600 lines of Julia code. Don't ask me how. It was painful. But I don't know if you've ever faced the fact that when you run into stale packages in Julia, you basically want to clone the person's brain and get them to explain the code for you. There's a lot of things that you want to be able to assert about that code that you don't have the context for anymore because we can overload types. And so different parts of the code base can call any other type or any other part. In Rust, they figured out that having the cognitive context of the entire code base is not a good scalable way to build complex systems, especially when people can die if you get it wrong. No? So the way that they face complexity and people interacting with code bases over time is to try and encode as many safe defaults into tools and not let people get away with cheating in a sense, no? Or doing the bad thing over time. Right. Once you start learning Rust, you'll see that about all of the context that you need to understand a function is reduced to the function itself. Like there's no checking where method overloads happened in other places. It becomes very straight line code in the sense of all of the Rust code that I've ever seen is basically the same as every other Rust code that I've ever seen. Raise your hand if you've ever seen a horrible variant of C++ in some code base that has nothing to do with every other variant of C++ you try to learn about. Right? Some more stories here and there. Yeah. Okay, it's horrible. Rust doesn't tend to diverge as wildly yet. It might. I don't think it will. No, but you don't tend to see like, oh, this is the boost version of Rust, right? That's like its own thing, and oh, this is the standard library version of Rust. And those are not accidents of happenstance. Those were social and technical engineering feats of people that took on the problem seriously of we are writing software to last for decades. No? As a fun aside, the creator of Rust actually, when he was like presenting it to Mozilla, the first times called his presentation Rust, a language from the past to save us from the future. And he made no amends about the fact that Rust is basically 80s and 90s type theory that is just exported into the systems programming domain. And he was like, yes, it's old, it's boring. If you meet the Haskell people, they're like, you don't even have fancy type classes. They don't care. It's like we have 2 or 3 tricks, good enough for us, good enough to be amazing. And at the top, they share this ethos with Julia, at least, of be greedy, right? Like you meet people and they're like, oh, pip takes forever. Python is just the worst at this. C++, you always get seg calls. And it sounds like people are talking about their toxic ex that they just can't leave. Have you ever, it's just like a learned helplessness, no? And so Julia people and Rust people at some point said, I'm sorry, technology can be improved. We can do better. Like our tools shouldn't be broken all the time. It shouldn't be that bad. Things can be improved. No, we have to keep using bubble sort or something. And I'm like, no, actually things can improve. So there's some psychological hangups of people who are like resigned to computers are hard, and so you have to be a macho and learn pointers, and you have to face these seg faults on your own, and it's very, very weird for me at least. So where do I think Rust is most worth it for Julians? What do people that have been using Rust have found purchase for it? Yeah, please. Right, so gRPC is serializing data back and forth, right? So that's, you're counting up the bytes and you're sending them over the wire and you don't want to use any more memory or round trips for it. Yeah, that's a classic case for Rust. Go for it.
Yeah, something similar. I have an antenna and I have to decode some packages really low level. And yeah, that was easy Rust.
Was it code that was written on an embedded device?
Yes.
Oh, cool. So we got sending data over the wire. We got embedded devices. Anybody else? Web service. Strings or Unicode? Yeah, well, we'll talk about strings and Unicode a little bit. So some of those are, I think I'm like, I don't think that I'm rediscovering anything new, but it's places that we know where Julia doesn't shine. No, that's where Rust tends to be great at it. And so resource constrained environments, I would include the cloud there because of money, right? There's a lot of workflows that have shifted over from Go towards Rust because of how much money they save just on memory bandwidth. Like, oh, your EC2 instant doesn't use 1,000 gajillion gigabytes. That's $1 million a month for some companies. And so they're willing to pay people to take our courses to learn Rust to put down their cloud costs. Critical safety, if you happen to know, my company, Fair Systems, released an open source compiler that's qualified. It's pretty cool, no? It's for automotive industry, but for people doing nuclear reactors or hospitals or medical appliances, Rust is, or Julia is not the place where you want to run that code. We're really good at composing code, trying out new things, coming back to them in 20 years is maybe not what the language was designed for. And that's fine, no? Your code, if your code's not going to be in production for more than 6 months, that's a different story. If you're going to put it in a car and have to answer for it for a couple of years, it's very different. It's also because it's also harder to sell Julia to people when it's part of an integrated process. So I've met a lot of people that need to manage some part of a data pipeline, no? And so they need to write a little shim for the database and telling them like, oh yeah, you just need to byte the Julia runtime of 160 megabytes all the time. And they're like, what? Or I can just give you a binary that I can cross compile with Rust and then use that. I came up with this principle. I just named it like 2 hours ago. But Božimir Kaminsky, one of the creators and main lead devs of data frames, kept mentioning that the least interesting part of your Julia code, at least for data frames, was the speed, right? It's all the other things that come after you have your results that are actually the most interesting. Oh, can I put, graph theory on top of this? Can I plot it? Can I add some statistics on top of that? Can I, parallelize it? Can I send over like a jillion other things that I want to do that are new and interesting? If you're a scientist or a STEM person or anyone that could be close to those needs, Julia's ability to compose code is like pure to none. It's not as interesting when you're coming from Rust. All right, so I've asked these four. I told you about that. We have Rust analyzers installed by now. Yeah, raise your hands. Sweet. So let's do a small demo of Rust Analyzer to just show you some basic capabilities that I think are not only useful, but are cool to show off. So Rust Analyzer is a LSP, language server protocol, that will allow us to, is that the right font, by the way? Is it better if I do that for the, oh no, people in the video? No? And what about a light theme? How do we feel about light themes? All right, no comment. We'll leave it there then.
It's better because it's so overlaid the background. Yeah.
Okay, so theme light plus. About. Okay, this to me is blasphemy, but all right, that's fine. So here's what's going on with my Rust setup. First point, if you ever start VS Code or Emacs or Vim, if you're one of those people with the big boy pants on and you're doing your own IDE setup, you. Remember to start the VS Code instance at the root of the folder. Otherwise, it's not going to get picked up. No? I have this red highlighting that's happening. That's an additional extension. This is how I install the Rust Analyzer extension. I just go here and I do Rust Analyzer, right? And then I go in and install that. Don't install any of the other ones. This is the good one. And then additionally, I will recommend ErrorLens. ErrorLens is going to show you when you make any sort of mistake. Okay, not coming up, but doesn't matter. So this red highlighting, if you didn't have that installed, you'd have to pull up your terminal and then do something like cargo check, right? Cargo check is when you only run the type checking. You don't ask it to build any binary, and this is made to be incredibly fast. No? You'll see that there's a really nice set of error message is displayed there that says, oh, actually, I found a range. You're asking for one thing, and I'm getting another. I want to steal more and more of this type of error reporting into Julia, and I want to push people that can do that work into doing more and more of it. Cool. What do I want to show? Cool. So some of the basic things that you'd expect with this tool would be, I can get auto completions in into iter. Then I can do a map, then a function, C+1, collect it, and then unfortunately, sometimes you have to do this additional syntax to let Rust know, oh, I actually know what I'm talking about. Like, what the hell? Oh. Can it be the reference? What? Okay. Can be the reference. So when I don't know what's happening, I do cargo check, and it says I haven't saved the file. Item iterator is here, required by bounded iterator. Iterator remains iterator here. But if type i32 cannot be built from that. Okay, weird. Ah, that's because I'm not summing. Silly me. And then after I do cargo check. Cool. So I had all sorts of type completions that were happening. I had syntactic errors that were fired off for me. Those are all well and good. Let me show you what some of the cooler parts of Rust Analyzer exist that aren't shown. So this is a format string. If I have a format string and then I write .print line, this dialog comes up. So there's a postfix notation. And so if I then type tab, it goes back and interpolates all of the different values. So I saw somebody go like, oh, that's new. Right. So I'm very lucky that some of my colleagues are actually the main maintainers of Rust Analyzer. No? And so I get to ask them very nerdy questions about, hey, what's this trick that you pulled off? And they're like, oh, actually, it's this part. The manual is incredibly long, and there's a crap ton of tips. I was recently, I did a video about these very tips. It's going to be uploaded pretty soon. No? But those were arbitrary expressions that were just interpolated there. No? That's the first step that you can get through with Rust Analyzer. No? Sometimes you can be writing your strings and then you do .println. Next tip, raise your hand if you know about match statements. Match statements, someone. Cool, we've heard about them. So match statements are a way to check if a value is of a certain type, and if its value matches a certain case, then we go into a certain branch or a certain arm. So this is an enum. It represents a sum type. You can have one of those three choices, but it's either a red or a green or a blue. It can't be both at the same time or a weird overlap. No? And then if you have a sum, that's what Rust people have for operations that may or may not have been found, right? So if I do a binary search and I'm looking for the number 15, it could be that my tree does not contain that. So I could either find the value 15, or I could have found none. Okay, we're not going to go into incredible depth about that here, but I just want to show those are constructs that you're going to be writing a lot in Rust. You're going to be juggling them. However, what's really cool is that I have this tuple here. This tuple is of two expressions, right? N divided by n, residue 3 and residue 5, no? And then if I do write dot match tab, no? So I can autocomplete that syntax. That's pretty cool, no? So you can write your fizz bus with some cool shenanigans there. However, in the case that I write, if I have a color, and the color is a type of enum, and I do the match. I'll also get the syntax filled out. But, and this is the really cool part, no? If you press Control period here, it'll fill out, you can fill out the match arms. So this is why I like doing this presentation, because this is not news for anyone in Rust. They're like, oh yeah, Rust Analyzer does that. And then I just saw 5 people just go, wow, in the crowd, no? And they're like, oh my God. And so part of the reason of doing this talk of like, hey, they have really cool things in Rustland. We should steal more of them, right? So that code will get you the different, they're called variants, right? One of the 3 cases of it's a color. Match only knows a type, no? And then it knows the type can be one of those 3 choices. So it says, look, I don't know what you're doing, buddy, but you got to handle all 3 of these choices. I don't care what the code is. So. Oh, excellent question. The to-do macro, actually, yeah. Yeah, so the question was, what is this to-do bang function? In Rust, right? So interestingly, if I do cargo check, code runs. No, it's not made up. But if I do cargo run, no. Okay, yeah, no, nothing's calling that. But if I have in my main function, right, I can do if 3 is less than 5, right? Println, great question. But then in the else case, I just do, you know what? I don't want to worry about it. Right? It's a way of, so if I didn't want to worry about the other branch, it's not like I can do that, or rather, I can do this. Let x equals 3. But Rust has to have both branches of an if have the same return type. If I don't want to write that return type, the other branch now, I can just say, Rust, shut the hell up, leave me alone. And so I'll let you do that. What? Right. So that's where I wanted to go with this. If you go with, what is it, 10? Then you get not yet implemented. You get a panic, no? And there's a couple of these convenience macros around, like, I think actually there's another one called unimplemented, right? One of the, so obviously if you hover, you'll get some tooltip here. This allows your code to type check, which is if you're prototyping. The difference between unimplemented and to do is that while to do conveys an intent, the message is not yet implemented, makes no such claims. So, no? Yes, in fact, that is such a good question, no? I'm learning Julia. I know that when a bang goes at the end of the name of a function, that means it mutates one of its arguments. Which one? I don't know, but one of them, right? That's something that if I was doing in Rust, that would be very, very weird. Is there some place where a bunch of these different syntax clashes for my expectations versus what's used in Rustland is written down? Yes. If you go to the repo, there's a Julia cheat sheet. And towards the end of it, there's a syntax clashes, no? This cheat sheet is part of the repo, but it's also part of our educational materials on our website, no? Those are footguns that I ran into where my expectation didn't match Rust's, no? And along somewhere here, there we go. Famously, the macro that most people run into. Oh my God, what did I do? There we go. Print line. Another function that ends with a bang is a macro. Mutation is more explicit in type system with a mute keyword on a binding basis. Right? Excellent question. And in fact, it's such a good question. I might show you something very, very trolly, which is, I believe, did you know this? In Rust, macros don't need, so what I showed is this. macro implementations in Rust don't need to have a parentheses to close over things. So that's also the reason why sometimes you'll see people write the syntax let x equals vec 1, 2, 3, right? The wrapping square brackets are just as valid as matching parentheses or matching squiggly braces. And if you do this, be prepared to have shoes thrown at you in Rust places. No, I'm just letting you know. But yeah, so moral of the story, there's a lot of places where your syntactic intuition is going to lead you afoul. I wrote a few, as many as I thought were relevant here. Okay. The cheat sheet goes on in quite a bit of detail on a bunch of different topics that I'm going to be mentioning later on. Thank you for that question. Yeah, please do.
You keep saying macros.
Yes.
Does my intuition translate from Julia?
Yes and no. Maybe I'll add to it. So what do I mean by macros? Macros are in Julia a way to manipulate the abstract syntax tree of expressions at parse time and output some code, which is not necessarily valid Julia code, right? You can produce invalid Julia code from an expression. You can, yes, you can return invalid expressions, no? In Rust, two different macro systems exist because they had to get 1.0 out the door. And the one they had was incredibly powerful, which is called procedural macros. Wait, I always get this mixed up. But there's macros that have the hashtag before them, and there's macros that have the bang after them. The macros that have the bang after them are, they look like regexes, no? I'll actually, I have an example here. This is what they're called macros by examples, right? So in that one, oh, that's a bit, that's much better, no? So here, this macro, I come up with a sort of regular expression syntax to match on some terms, and then it expands to the expression on the right, no? I can write different cases for if you see this expression, please expand to this other case. So this macro system is also guaranteed to be hygienic, if you happen to know that word, no? But it just means that you don't pollute the namespace of where you're defining the new variables in that new scope and where they're coming from. You're also not operating directly on the abstract syntax tree itself, but rather on tokens. There's like a few details there that are like, you're not getting exactly the same behavior, but it just means that you can't produce invalid Rust code from one of these macros. Okay. There's also a more powerful version of macros that actually does let you like hook into the most generic version of like all of the parsing infrastructure, but so if you see the hashtag there, allow that, like that's being applied to the next expression block. No? Those you can also write, and those are, so that's what I mean by you can have the macros with a hashtag or the macros with a bang. No? So if you remember anything from any JuliaCon presentations, there's a really good one by Stephen G. Johnson on, stage programming and macros and functions. And his advice is don't write macros. I would echo that in Rust. If you need a macro, you probably don't, unless you've been coding in it for like 6 months at least, if not a year. Just write a silly function, just write a simple function. What else? Yeah, you are more likely to be a user of macros and just be like, oh, this works as I expected to, than need to figure out how to write your own macros. No, obviously, if you want to do it for fun and for fun and giggles, then go for it. But it is infrequent that you need to write a macro for something. And the same reason why you would write a macro in Julia is why you would write one in Rust. You can actually, someone wrote a crate, which is the name for a Rust package, for writing array comprehensions a la Python in Rust. That's one of my biggest pain points. Getting like just generating data for my little projects is so annoying in Rust. Trying to get a random integer is super annoying. Super annoying. I'm spoiled by Julia. Okay. We're still going with the demo, right? But that was a great questions. I like that. Cool. Another thing that's very useful is that the way that Rust does type analyses lets it know the type of expressions as it's going down the expression, right? So this means that if you go into your settings, you can change this, but I can press Control and Alt on my keyboard, please. Yeah. And so those are the expressions up to that point in the code, no? If I just do this and I hover over it, then Rust will tell me, oh, that's actually a range, no? If I do this and I highlight that, it'll say, oh, you're actually constructing a filter over a range. This is a way that they implement iterators. If you haven't seen iterators before, it's kind of a more functional style way of coding in loops. This is very useful because that loop I can turn into a parallel loop with a single line of code. We're gonna go into that when I get to the live coding part. But if I want to know, hey, no, what about this expression inside of there? What's that precisely? Oh, I know that returns a Boolean. No? So there's a lot of places where you can just hover over the data and you'll get important information out of it. Cool. I would find that very useful in Julia to just like know the types of expressions along the way in my function. All right, this one's just a flex, which I think is so nice. So if you get the ISBN for the book, and then you place your cursor here at the end, so that's a valid JSON struct, but note also that it's a nested JSON struct, right? There's an author field inside of there. Whenever you see the light bulb, it means that something magical can be done by Rust Analyzer, or you can press Control period. Convert JSON to struct. That's pretty neat, no? It detected that there was an author field. It knows that it's a string, an integer, and then in line number 4, it knows that the author struct goes in the author field. You don't have your own custom JSON unless you clone my repo, but you can imagine. So this just goes to show Rust Analyzer was implemented first inside of the Rust compiler, and then it had to branch out. They've had to duplicate a lot of work because they have to basically re-implement a lot of the compiler internals. That is very, very painful. But they've done a lot of that work. And so that means that not only, I showed you examples where you can parse for, like Rust Analyzer can understand what's going after you keep on typing, before, so some of the context of your cursor and before that, but also not only Rust code, no? We're parsing JSON and emitting valid Rust code afterwards. Like that's a superset of Rust. Expected item found for a full list. I think that's because expected item. That's because I wrote yeah, okay. Weird. Maybe it should have inserted a space there. Interesting though. Okay. Sorry? Yeah, I don't know why. Is it the name? Let's see. Or no. I think it was just stale analysis. Yeah, we'll see a way in which we can keep on saving our file and getting it out. So I just said something that is kind of contradictory. I've mentioned that Rust errors are super well crafted, that Rust Analyzer is very, very well done. And then I've shown you places where cargo check can show you like, oh, there's an ASCII little diagram of like how you can fix your error. But those are two independent systems. In fact, why didn't the extension or Rust Analyzer show me like, oh, there's actually nothing wrong here? Unfortunately, the standard answer today is there's some errors that are better to get through the extension or through error lens, right, for immediate feedback. and some errors are much better to learn through the ASCII diagram that gets printed out by the compiler later. This is why I advocate for people to have an extension running, and also for certain places, we're going to see a way in which you can have your code in the background continuously running. In fact, why don't we just do that now? So, yes. No, that's Rust Analyzer. So in theory, if you have that installed in NeoVim, it would work the same. No, so none of the actions that I just did are exclusive to VS Code. Those would work in Emacs or Vim or Nano. I don't know. No. So I will now do cargo bin install cargo watch. Did not supply a GitHub token. What in the? Okay, so ignore the GitHub token stuff. I don't know what that is. But cargo bin install will just say, this will install the following binaries, cargo watch. Do you wish to continue? And I'll say, yes. Ta-da! And then I didn't need to build anything from source. What is cargo watch? Cargo watch will let me do something like check cargo X, then check cargo X build -X run. And so this will continuously be running cargo check. If that succeeds, it'll run cargo build. If that succeeds, it runs cargo run. Huh? So you can chain those, and I can just be editing this happily away. I can add a space. If I save my file, and then here, field ISBN should have a snake case. All right, weird, but let's go for it. And so I can just, whenever that's the rerunning is happening in the background, no, at any point in time. I don't know why it wants that. That's so weird. E.g. is bin. Oh, it's detecting like is binary or something. So I should have snake case name. Let's just make it happy. Okay, and then ta-da! This was running. It ran the check. That was successful. Then it ran build. Then it ran run. No, so cargo watch is one of the easiest way, or one of the dirt simple ways of having like this interactivity not get behind you. Rust has also optimized a lot of the path of how do I get incremental compile times to be very, very fast, unless you're working on incredibly beefy projects. If you're working on your personal projects or something small, like an antenna receiver, or like sending some stuff over the wire, this is probably going to be within interactive speeds for you. No? If you want a fancier version of that, you can do cargo bin install bacon, because someone figured out cargo watch is kind of not the best interface for that. If I'm already building a terminal interface, why don't we just go all out and give it nice colors and stuff? Huh? Whoa. Okay, this should not have happened. But we can keep on going with the presentation while that's going on. Yeah.
Can cargo watch integrate like you wait another half second and then you get the range that cargo or the rest that showing up in LSP as narrative.
Can you be a bit more? Can you explain that again?
So Rust Analyzer. So can Rust Analyzer integrate with so that you then get the error messages from cargo from Rust C as well as the error messages that the Rust Analyzer is producing?
I think they both get, so Rust Analyzer is triggered on save. Does that help answer your question? Like, there's no, Rust Analyzer is basically running its own version of the compiler. I don't know that it's, so your question is, can I have Rust Analyzer fire off again if cargo watch, so like if the check is successful, only then.
Or if you get back in here, right? Like the thought would be like if cargo watch start running its compiler, LSP has already done it. The Rust Analyzer has already done its thing. It's giving you its own
right.
error left. But then cargo then gets back to you saying, oh, the error is here. It would be nice if that then also showed up as a notification.
Yeah, I don't know for sure, but let me show you. if this thing ended up installing. Okay, cool. Bacon. So if you run Bacon, what's cool is that I'll press the question mark, no? And here somebody figured out, oh, actually, sometimes I'll just want to, you know, if I have a 300 error messages, I want the least or the one at the topmost level, or I want them in reverse order, or only show me one at a time, or only run check for now. So you can work with all of those presets in a very well put together TUI if you're working with that, no? I'm a Julia person. I love the REPL. I think this is as close as you can get to an interactive workflow in that domain. I'll be using this in the live demo, live coding part of the demo when I get further on. No? So I could, if I press R here, it's going to keep rerunning run. No. So if I change this to that, then it gets re-triggered on save or something, and then I can press quit and exit that. So Bacon is the super snazzy TUI colorful version of Cargo Watch X check build. No. Other questions before I go into my last tip and demo of Rust Analyzer. Okay. So something super cool that you can also do here is that you can do Control-Shift-P. I can bring up the Command-Shift palette. I don't know how you do this in Emacs. I'm sorry. You can probably figure it out. Sorry. Recursive, macro, expand macro recursively, caret, right? So if I do that, this is something I really wish I had in Julia. It's going to unfold the macro, right? And show me what it would look like at that invocation. So that happened at one level, right? So add bang just did X and then X plus 1. If I do this here, I think, okay. Picking that up. That's fine. Or, yeah, I should have done an additional one. I don't know why it didn't pick it up. But the point is, they just have a lot of really, really nice tooling. And when you see it, you're like, oh, I want that. So there is definitely a lobbying pitch for me in doing these sorts of workshops where the more people know Rust and Julia, the more we can be like, hey, things can be improved. Things can get better. Let's steal this good thing they did. And they're more than happy to. Like, the Rust people are pretty chill. So they would be very, very happy to see more and more people get better error messages. Cool. We're coming up on the break, first break. So I talked a little bit about why learning Rust for Julia people in particular is different. So we have the cells for performance or ergonomics or package manager are kind of not the best cells for us. Just have to go straight for. So the other thing that happens is that the more serious advantage that Rust has is that it has memory safety. And by memory safety, I mean that there's a subset of Rust called safe Rust, and that is where you don't use unsafe. No? They were very smart about teaching the compiler a lot of types that let them figure out how to write concurrent code and memory safe code. And they were able to do that through types. You can't do that for every single possible program. And so they figured out, you know what? That's probably equivalent to the halting problem. We don't have the time or resources. We don't have the desire. We are going to say, if you want to assure the compiler that you can do that part manually, you can do that only if and only if you opt into it. And you can do that through the unsafe escape hatch, right? It doesn't mean YOLO, I get to do all of my, I get to do all my own stuff. I'm in C mode. It means I'm now the compiler. I'm responsible for upholding the invariance that the compiler expects. Why am I mentioning this? If you're a Julia person and then you want to write, a deserializer, not a deserializer, but rather a embedded system, or you're talking with your hardware, the thing that you have to write eventually is unsafe. No other people that I know of go up to me and say, hey, I'd like to get some intro to Rust, but I really need to start doing unsafe. It's just like, why? I know dozens of Julia programmers. None of them need unsafe for basically all of their professional lives, except for rare once in a blue moon days. And the Julia people are like, yeah, it's the first thing I need. Crap, no? It's very unfortunate that you also get to hear all of this marketing on how it's so safe and so ergonomic and so happy. And then the first thing you need to do is do away with that and start using unsafe, right? It's a super deflating experience, at least for beginners, no? Also, interestingly, we're very much used to thinking about the memory footprint of our code. Like, we worry about allocations, we count them, we have benchmarking. Like, that's not very much what TypeScript or Go or Python people tend to be doing all the time, but we're very happy to when we're benchmarking. And so that gives Julia people an intuition for allocations and how memory can work. But also, Julia's memory model matches C++ semantics, at least with regards to structs, no, with regards to memory layouts. So we share the same memory layout intuition that C++ and Rust people do. And so the conversation with us is not like, oh, well, actually, all of your objects have a pointer interaction. It's like, no, they don't. And very few there's basically no educational material that caters towards like having that previous intuition. Yep. Also, interestingly, because we have a JIT, it's very similar to what Rust has with what they call monomorphization. No, if you have generics in Rust, or rather, if you have generics in Java, you pay a price for it. If you have generics in Go, you pay a price for it. If you have generics in Rust, then your own version of the code gets JIT specialized. Wink, wink, not that, but it's good enough for us. No, so a specialized version of your code will be copy pasted into the function call site, and that's called monomorphization. So I mentioned that I wrote a cheat sheet for Julians. Let me show you what I mean by a cheat sheet. Part of the web page or GitHub is a link to our learning materials. There we go. And our learning materials look something like this. This is literally what I use to train people. No. And so I'll go and click on the overview slides. And so I'll be like, hey, welcome to your first day on your training. This is the open intro. This is the intro to Rust or something. And I'll start saying like, oh, these are our slides. This is what syntax usually looks like. We'll get a cool button here. And if you click it, it sends you to the Rust playground. No? I have my speaker notes too. That's fine. No? Those are like our slides usually. Excellent. Those are all the topics that we say a beginner or would be fundamentals. Once you are done with those Rust fundamentals topics, you are good enough to start being somewhat, I wasn't going to say productive, but rather you can start writing out your own Rust scripts. No? Once you're done with the applied Rust, you are basically 80% of the way there to collaborating with your team, no? Being somewhat productive, which is very different from the experience of like, hey, you want to learn Julia? Take these 3 days. You can start helping out the team with some, unless you're doing some nasty generated functions, right? Like you can start using Julia code pretty fast. What I did for the cheat sheet was looked at these types or looked at every single one of these slides and then said, you know what? It would be very useful to have how basic types in Rust differ from Julia and what are those mismatched expectations. And how can what would I have wanted to know if I want to learn Rust version of control flow or compound types or ownership environment or error handling? Spoiler alert, that's exactly what you get with the Julia cheat sheet. No? And it goes topic by topic. Nope. Basic types. No? So Rust defaults to I32 and F64 numeric literals, while Julia uses int, the integer pointer width on your machine. Rust uses usize for that, and you'll have to index arrays with that type. So xi as usize will be a beta in your code. No, that's something that somebody was going to tell me at some point. Also, you can have the underscores there. There's specific suffixes like 1.0 underscore F32. Your numerical will have to have these cats that are very ugly, and so that's the stuff that you would learn if you were coming from Python or Go or JavaScript, whatever. You would get the slides that I just showed you, and then I would say, by the way, you're a Julian, please read this, save yourself some grief, no? So I've done that for basically all of the entries there. Let me know what you think. Pull request accept, pull requests more than welcome. There's some here that points here that I think are bangers. Yeah, I had a lot of help from Sriram Krishnamurthy and some other people from the hashtag Rust channel in the Julia Slack. I'm very grateful to them, so shout outs to you. Thank you very much for the feedback. Part of this presentation could not have existed without them helping out. Yes, there we go. There we go. So what I wanted to do now is to try and talk about we're going to have a break in 2 minutes. And then I wanted to let people here via show of hands or voting, ask for any one of these to be, so that we can go over either strings or traits or iterators or ownership. Ownership would be cool, I think. And also because I have a little experiment and or activity that I would really like for people to try out. I guess you can let me know when we come back from the break, which one you'd prefer. That sound cool? All right. The ownership experiment, if you please, is this. Go to the page. Where's my page? Oh my God, I hate this. If you go to this page, there's a link here to the ownership experiment. And just wait for me until we.
In 5 minutes.
Perfect. I'll be waiting for people here. So if you can please load the link on the GitHub. We'll see you in 5. Cool.
The coffee break starts in 5 minutes.
The coffee break starts in 5 minutes. All right. Raise your hand when, or can you let me know when you've joined this page? Yeah, this will be a good thing to try out just before we leave. Yeah. JuliaCon Rust Workshop 2024, Miguel, GitHub. Feed that into Google. And then it's the ownership experiment link. Yes. So can you clap once you get there so I know? Okay.
I'm sorry, I'm still having trouble getting it down.
No worries. Maybe I can move. Who still needs help getting to 0? No?
I think I'm just for misspelling the
Yeah. Boom. First touch screen. All right. So. Excellent. I see 14 people there. All right. When your instructor tells you, so this is going to be our motivating case for how the ownership system works in Rust. Cursor on one of the 3 bullet points, and then the point is to write who you think are the top 10 best-selling artists of all time, however you think that they are. It could be Bach, it could be Britney Spears, I don't care, no? When I say go, please write out your answers, no? On that list there. Are the instructions clear for everyone? Yes? Ready to type? All right. Ready, set, go. Yes, yes, yes. All right, we have Beats, Beatles, Queen, 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 Queen. All right, I think that's good enough. We didn't get to 10. All right, please. And we have Taylor again on 7. All right, stop. Perfect. This is amazing. What happened? Does anyone know the name of the problem we just faced? The more generic name. But yes, it's a race condition, right? There's a lot of us, there's one Google document, and we're all trying to write the same answer in the same place in memory. Right? there's a cool guy called Leslie Lamport, and he figured out like 50 years ago. This is called the mutual exclusion problem. And we're going to think of different ways to solve that and go into the coffee break. When we come back, I'll tell you the Rust approach and how it's going to be beneficial to think about it. Okay? But thank you very much. I did not know Beatles Queen One Direction Taylor Swift. Michael Jackson was the top selling artist of all time. Or that Beatles Queen Beatles and Swift. Huh? Let's get into it. Come on.
I think last time I had the brown one. Yeah, which one? Yeah, they give this one. Oh, it's from us. And the Julian one. Oh, you put this one. No, it's not weird, but yeah. It's nothing cool because it doesn't say what it is. But we decided to tell them thanks. Have you been here online? Yeah, it's this one. I'm not here at the, not here at the, when you arrived for yesterday. I'm only glad that I asked them.
You're gonna be fine. Like, but unless there's the most valuable experience, you're doing Emacs, you know, it's not. And also, if you move to the Rust analyzer page, then you'll have the problems again. It's just, I'm curious what your actual process is. Yeah, at some point I think it's so really simple. But I think part of the is should be that money was the so that's the thing. So there's way more people now. There's way more streaming. And so it's not the same like people trying to find the right. But it's all close now. It could be that's why I don't really care. It's more like people will write out. Hey, maybe it could be based on. That's not the important part. The important, the funny bit is that you can get people to write directions to the street final direction. You know? And then you're like, all right, when is this happening? This is always like randomly generated. We've had like picnics years off. I find this thing. It's really cool. Because yes, it's a race match. But you let me know how well I do that.
Insights and pros and cons. What things we have similar to what things are distinct.
The biggest We're missing one person on our computer, another person there. Okay. You're welcome to stay. Do you know about Direction Taylor Swift, Michael Jackson? Okay. Yeah. All right. We're back. Can anyone recap what happened before we left for a coffee break? Raise your voice. Just like this experiment itself. Can anyone recap what happened here? What behavior did we observe? I don't know what a CRDT is, and I remember reading about it.
Yeah, it's a data structure for current lines where you merge them together.
Yeah. All right. Ignore that something fancy happened.
Okay.
No, just like we had a Google Doc that we all try to run right into, and then we ended up with something that was clearly a garbled answer. No, in theory, this should not have happened. Question: how could we have prevented this from happening? We all want to edit the same Google Doc or whatever. How could we have prevented that? Please. So a mutex. Cool. A mutex on what? So a mutex on the file itself, a mutex on the line, a mutex on, there's different options, no? On the what? On the cursor position. So it could be incredibly fine-grained, no? On the cursor position. Somebody else could say, actually, let's just do it by places. Just the first place will have a mutex on that only until someone is done writing Taylor Swift, Michael Jackson. Will that be over? No? So the people that went with put a mutex on everything are called the Java people, and that's their concurrency story. No? What's another option that we could have done in order to get around this problem? What's another strategy? We could have given every single one of you a copy. Everyone writes out their answers, and then we have a smart way of merging it in the end. No? Does anyone know of what kind of functional? Does anyone know what kind of programming languages would have taken that approach? Yes, correct. It's a functional language. They give everyone a copy of memory, and then they pull them all back together, right? So our options could have been. We start handing out mutexes, we give copies to everyone. Those were fine answers for some programming languages, but Rust went with an answer that is basically, we're gonna make you prove at compile time that only one person is writing to this entire document. It could have been incredibly clever. It could have had a CRDT, it could have had a mutex on the line, it could have had a mutex on the character position. Rust people said, screw that. Let's just call the whole Google Doc a resource or a variable or a region of memory. And let's just say you have to prove to our compiler one and only one person is editing that at a time. It's not a problem if all of us are looking at the same document. So we can have n readers, right? We can have n shared references to the same document. But if one person is editing it, then everybody else could have like their data updated behind their back. No? I've just explained the fundamentals of the result of the ownership system, okay? And that's what I want to go into and explain. So could you please, no? Ownership tomorrow, no? So it's the basis for the memory management of Rust. The rules are really simple, but just because something is simple doesn't mean that you master them. Chess is simple. There's like 12 rules. Just because I know the rules of chess does not make me a grandmaster. There's like 4 rules of the ownership system. It takes a long time to master them, no? So the rules are, every value has exactly one owner. Ownership can be passed on, both to functions and other types. The owner is responsible for removing the data from memory, and the owner always has full control over the data and can mutate it. So besides the ones of like who is responsible for it, the first one and the last one are what guarantees us mutual exclusion. No? Only one person is editing this thing at a time. The other 2 have to do with cleanup. No? Ownership can be passed on. I can say, I am no longer responsible. Then please have that. Or I can say, and then the last one is the owner is responsible for removing the data from memory. That part about how data is removed from memory is the one that's missing from our intuition as Julia people. We have a garbage collector that saves us the stress of learning any of these details. No? I'm going to go into a bit of detail now, trying to coax you into learning about it. No? So much like multiple dispatch is fundamental to how everything works in Rust, the ownership system is fundamental to how everything works. Wait, multiple dispatch is fundamental to how everything works in Julia. The ownership system is fundamental to how everything works in Rust. You can't write your structs without taking it into account, basically, or not the implementations. It's enforced at compile time, and it's important for optimizations. No? This is a beginner example. I have my main function. I'm going to define the string, hello, smiley, and then I'm going to print the string. I now have a function on line 7 that says, print the string s. Okay? Now this code is allowed to run. By the way, does everyone know what this is? The Rust playground? I'm going to be talking about it when I get back to the live demo. But if I try to do, oh no, I don't have my Vim config here. But if I try to do print string again, and I run it, then unfortunately it says use of move value s. Move occurs because s has type string, which does not implement the copy trait. Value is moved, value used here after move. Rust is protecting me from a use after free. Thank you very much for the picture. I really appreciate it. It's a video. Oh my God, no. All right, if people want to take pictures of me and then tag me on LinkedIn or Twitter, I'd really appreciate it. Help me prove to my employer I actually did some honest work. But unfortunately, this does not compile. So what we're going to learn is that there's a couple of visual tricks that you can start working on in order to detect what we mean with resources and where they can still be used. No? And it doesn't. So please look at the signature on line 7. I know that the types are the other way around than from how we usually do it in Julia, but we have S semicolon, then big string. I'm going to call it big string because it has a capital S, but that string, no? Who is the value of S on line 2? It's actually the variable S, no? Or rather, it's the owner of the string hello smiley. When you call print underscore string, because of the type definition on line 7, that basically means whatever argument you give me, I am now the owner of it. Okay? If you feed me an S, I am the owner of it. And that means, because of our rules, that I am the one that has to deallocate it. No? The Rust ownership system will guarantee you, with all the king's horses and all the king's men, that if you obey its rules, you'll never get a memory safety issue. You can get a memory leak, which they don't define it as a memory safety issue. That's different. It doesn't affect the correctness of your program. No, it might affect the runtime behavior or the runtime characteristics, but it doesn't affect the correctness. So when you feed something to the print string function, it's going to take ownership of it. And then after line 8, it's responsible for that. but the function is going out of scope. So it's going to introduce a drop. A drop is going to be I'm done with this memory, and so is everyone else. I'm deallocating it. No, it actually doesn't deallocate it. It just says this memory is no longer available. When it actually happens is up to the optimizer. Okay, so we don't really know when it's being deallocated, but we know it's untouchable after that. No. Once that happens, so now that we know that, I think this is going to be explained just here. No. At that moment, ownership passes to print string. We say the function consume the value. No. You absorb it into print string, and then the variable binding s ceases to exist, and thus main is not allowed to access it anymore. So you are not allowed to, once again, use s after line 3. This is what I meant with these visual tricks. If I see a function defined like 7, where it's taking the ownership of s, it's only calling on s, no, there's no ampersand afterwards, and then I see something like line 3, where I'm calling print string on s, if I ever use s again afterwards, it's wrong, according to Rust, no? For types that are not trivially clonable. Like if that was an integer, Rust is smart enough to say like, an integer you can just copy around, not a problem. But if it's a string you actually, it's allocated on the heap, and so somebody needs to worry about those things, no? So. Can you state the question again?
Like, is this like, so now you can use S only once.
Uh-huh.
Is that because it's passed by reference? So it would change.
So the S is not being passed by reference here. No, we're going to see later on. So that's something that gets people that come from C, C++. It's very, very important to know if things are passed by reference or by value, because it implies a copy sometimes, no? And then you have to override, or you have to know the defaults that can happen on certain different types. In Rust, except for extremely obvious cases, things will not be cloned implicitly for you, no? And so that's one of the other things where I try to mention before, like Rust is extremely explicit. And as a Julia person, it's going to be very annoying at first, how they really want to know everything up front. But when you come back to the same code after 6 months, you're like, oh, all of these places are where I'm seeing clones. All of these places is where I'm seeing runtime dispatches. All of these places are where I'm seeing heap allocations. Oh, that's very nice to know up front, no? So a string is actually communicated as a pointer and a length in this case. So you'll still have to go to memory in that sense. You'll have to chase a pointer, but it's not when we talk about being passed by reference in Rust, we'll get to see that type signature in just a second, no? But it's something that can also be optimized away, no? In many cases. So the other super important thing that we don't have in Julia, there is no concept of making your bindings immutable. By binding, I mean like the name X, no? If I add the other X plus 1, that's going to fail, no? I need to annotate my X with mute X. So if you've tried Rust, I don't know the people that are more proficient with Rust here, but I remember the experience of writing a binary search in Rust. I was like, all right, I know my Rust. I think I can do this. I couldn't. But after I did it, I got it to work. And then the Rust analyzer would say, oh, by the way, you don't need to have these variables be mutable. Like, that's not a thing. And I realized, oh, crap, my whole algorithm, I had a bunch more things be mutable than needed to be. And so once I took that away, I was like, oh, right, I only need to make mutable like the top and the bottom index of a binary search. Those are the things I'm modifying. Everything else I don't need to worry about. All of those other things are immutable. So what ends up happening is that you start to see things as, this doesn't change, I don't need to worry about it. And that's something that Rust started training me in as I became more and more familiar with mutability. So it would be very annoying. In fact, it was very annoying to code in Rust if you could only ever do takeover objects. No, if you could only have the ownership. There's this concept where you can say, actually, you can have the memory for a while I'll lend it to you, or that's called taking a borrow. So you can transfer it to someone, and they can do some things with it. So, Scott, if I lend you my car, you're allowed to do some things with the car. Obviously, you can drive it, you can put some gas into it, but you can't like change the paint on it, no? Hopefully. No? However, if you take ownership of the car, if you buy it, you can do a lot more things. So there's this inverse relationship between how much of it you own versus which things you can do on it. So depending on if it's owned or borrowed, there's a certain amount of API that is closed or open to you. In the reverse case, and that's very interesting, as you start to design APIs in Rust, you can start to think of which APIs do I want to expose to people. Okay, I don't want them to mutate this, so I'll make this immutable. And so you start to think in terms, like the ownership system will guide you towards thinking of, oh, this means that if I only give them an immutable object, they can't do these other things that are bad with it. Whereas with Julia, you could just start mutating my object. I don't want that. No, we have a fairly good discipline in recognized packages of adding like bang functions, but not all functions have a bang at the end. And if they're IO functions, that's also going to be problematic. No, and we also don't know which objects are the ones that are being modified. So knowing at the we're going to see it in maybe just a second, at the implementation level, these are all the things that I know can be changed about the logic that I'm handling. Is super, super liberating. I don't have to care about that anymore. The compiler is taking care of it for me. No? So the outcome of a borrow is a reference. A reference is a pointer with additional typing semantics of how long it's valid for. If you come from C++, they're close to unique pointers, but unique pointers are always atomically enforced or implemented with atomics. Because they figured out this whole type system, Rust can do that without atomics. And so smart pointers in Rust, in the single thread case, are much faster because they don't have to be atomic by default. Type systems, they work, right? All right. Last thing about the slide, there's two types of reference. There's shared / immutable, and there's exclusive or mutable. The old terms were immutable and mutable. The new terms are shared or exclusive references. You're going to see precisely what I mean in just a second. So a shared reference is, it uses the ampersand. So you have to start training your Julia eyes. Whenever you see an ampersand in a function definition, that just means this thing does not change. Okay, this thing is immutable. It's like a C pointer, but with special compile time checks. Rust also allows type conversion functions to be called when you take a reference. There's some ergonomics so that you don't have to be worrying about, am I looking at the thing or the dereference of it? For people who come from C, it's very, very annoying that you have to worry about, is this the thing or is this the thing that I have to go and chase the pointer of? No? What I mean specifically is you can have a string on line 2, then you can take the reference on line S, and then you can get back the string slice. So a string slice in Rust means that you have a container and then you also have a length for it. No? It's like if someone told you, I give you a type that lets you know that you are looking at a vector that is alive and that is of length 100. That's what a slice means in Rust. It's also part of the syntax clashes in the cheat sheet, because slice for us means, oh, you're operating on an array. You better put the add views on it, otherwise you're copying. Nothing to do with Rust, okay? Slice for them means you're looking at a container and you're adding a length via the type, no? The ampersand is very powerful and it carries that meaning, okay? So whenever we see a naked ampersand, that means this type is immutable, no? Except for a very rare case, don't worry about it, no? And so what ends up happening is that once you start being more comfortable with Rust, you can start writing your function signatures with the ampersand in front of the type. And that's saying, I know that this S argument doesn't change. And whenever someone calls this function, they can take a borrow of it. No, you're lending them the data, right? I'm lending Scott my car. I know he's not going to paint it like bright neon pink, and so I can have it back when he's done with it, and I know it will go through no damage. No? So if that happens, I'm very happy to lend Scott my car as many times as he wants. I can lend print string twice. right? Because the memory is not being destroyed because no one took ownership of it. There's no new owner. It's not being deallocated at the end. So far, so good. Okay. That is different from an exclusive reference. In an exclusive reference, I would say, hey, Scott, not only are you allowed to borrow my car, you are now the owner of it, no? And like, please give it back at the end when you're done with it. Maybe we needed to do some legal shenanigans. How it looks like in Rust is that you have an ampersand mute, and you're saying, I want to borrow it, and I want to be able to modify the car. I want to put spoilers and neon lights. Even stricter, so that's what I meant with the amount of API that gets exposed. If you have only a reference to something, you can do some things. If you have an ampersand mute, you have access to more API. You can do more things on that object, right? Now you can mutate it. Only mutable binding can make a mutable reference. So mutable references, if you remember anything from distributed algorithms, they match up to what your intuition would be for solving the mutual exclusion problem. Or how do we not clobber over each other's Taylor Swift, Michael Jackson artists? No? There is a reference to an object at any one point in time. We cannot have more than one exclusive reference allowed at the same time. And the compiler knows an ampersand mute reference cannot alias anything. Basically, you can have one mutable writer, XOR, and shared readers, right? Either everyone's just looking at the document or someone can be editing the document. Cool. And this is the part about forbidding shared mutability and getting an exclusive reference. You can add the ampersand mute in front of it, in front of the S, and then from there on, you have an exclusive reference type. Now, if I want to modify the S string, I can do s.push str. And so if I want to add the excitement, I can do this string is hello smiley and then s.push stir. And then we'll just run that. Any questions so far?
Do you mean mutable reference on your variables defined as mutable? Like here you have
yes.
S, but if you have let mutable, like only let S, that would fail.
Right. So you can do this, and we'll see that's going to fail. Cannot borrow S as mutable as it is not declared as mutable. But want to know some cheat codes? Here's the cheat code. Let mute S equals S. And this will get you kicked out of Rust conferences. No, just kidding. So this is very useful because this is completely in agreement with the ownership system rules. There was an S owner who declared it immutable. There is now a new owner who declares their S variable mutable. You can from now on mutate it. There's a new owner in town. They can do what they want. That's valid. What ends up actually being a pattern sometimes is this one. You'll do let mute S, then you'll do some foo on ampersand mute S, right? You'll mutate it a bunch, and then you do let S equals S. So I know that everything between lines 3 and 5 is all of the possible places where my S resource could have been mutated. After that, I know that it can't be mutated anymore. So that's another way where you can sort of encapsulate immutability into your program. No, it's usually when people are building out constructors, no? And so you're like populating some data, and then when you're done with it and you want to give it off to someone else, you're like, okay, this object is immutable, and then you do that. Yes. This case is super easy because I have only one reference. Once you start to have two or references in the result type, it can get tricky. And I specifically did not want to get into that in this talk because it means it means that I have to tell you about lifetimes. And lifetimes are a way for the compiler to think about, hey, we came up with this permission system for when people can edit the Google Doc, no? But I'm a compiler. I have to know how long that permission lives on for, how long that region of memory has to be valid for. Okay? So far, so good? Exactly. So if you don't have a garbage collector, I have to be able, as a compiler, to know at compile time how long things live for. So the system that they came up with is called lifetimes. I know that this region of memory can live for this long. No? For certain special cases, so like the function only taking in the S, I know that it's fine for me not to ask you what the explicit name of the lifetime is. Eventually, once you start writing more and more Rust code, the compiler can't figure that out. It's not just that it can't figure it out, it's probably unsolvable by the compiler. So you have to start playing with the different tags on how it works. And Mhm. You could, yes. So technically, the immutable thing could be jacked onto Julia, or a safe gradual variant of it. Wink, wink, nudge, nudge. I don't know. So one of the interesting lines of thinking that some people that are much more illustrated in this than I am could comment on is there's maybe more strict subsets of Julia that people could opt into, right? Whether you could say like, oh, this is a safer Julia version that I want to enforce for this module, no? So here, I want to know that you're always annotating with a mutable keyword, that you're always annotating, that you're always handling references in this case, that if you get a nothing, you're handling that case, if you, so on and so forth, no? That could happen. It'd be interesting. I'm not sure how it would happen. Other people have done similar things with like, I think it's called liquid Haskell, where they start adding gradual types. Sorry, go on.
I wanted to ask about the let blocks, because I get confused.
The which blocks?
Let.
Oh, let.
That one is confused versus Julia, right? Because Julia is
Yeah, it's just so.
not read it in Rust, basically just define variable.
So, yeah, it just means define this variable. That's the.
Would it work without the let? Or
No, it does not. So this, the one thing that is allowed, I think, is if I do this and then, so if I do let mut x equals 1, and then here I can do x equals 2, that's allowed. Once you declare, so once you declare it once, you can change the binding later on.
Yeah.
But let is for declaring the binding. Yeah. Also, interestingly, you can do that delayed initialization, which I hate. Yeah.
Like Julia said, you're looking at the performance mutating function, and then you have a non-mutating function that maybe allocates memory first and then calls the mutating function. That a pattern that exists in Rust as well, where people basically have unsafe Rust or whatever. Okay, that's another concept still.
Mhm.
But basically, you call this from another function.
Yes, and right, and the way in which it would show up would be, let's just write it here. You could have something like fun make a foo, and then I would take some object that is object, no? And then I will give you back another object, right? And this is just like a obj clone, no? Or something like that. And then you could have fun make, so you would want this function to also exist, right? It doesn't. That's why I'm mentioning it. No? So I think you could do make foo in place or something. But Yeah, so Rust doesn't allow you to even single dispatch, I believe, except for very special cases like arithmetic operators. But you can't, yeah, this is not a thing. You're not allowed to have a single dispatch, I think. Yeah, build. But documentation that doesn't come in, what? Oh, it has an intrinsic documentation system. If you have 3 slashes, then it tries to build Markdown out of it. The name make foo is defined multiple times. Yeah, you can't do that. Consider importing this trait, blah, blah, blah. Oh, I don't even have it. Yeah, to be correct, to be complete. String, and then, sorry, yeah.
Can you have made one like string and integer, for example?
So integer is going to be a cop out. It's going to be cheating because when you try to take ownership of an integer, because it's primitive bits type, taking a clone of it is so cheap that the Rust compiler says, oh, you can just clone this. In fact, the answer to a lot of your Rust problems is just clone memory, because if everyone gets their copy, we don't have a problem. No, everyone can own their own thing. No,
No, but I mean, here you have string and multi, but it's basically the same type. So can you have like string and something else, like
oh,
string and I don't know, vector.
nope.
Okay.
Yeah. Cool. Yes, and one of my recurring gripes is I really want a really cool linear algebra library in Rust, and one of them is being written, but it doesn't have multiple dispatch as we know and love it. Maybe there might be ways to get like a version of multiple dispatch on structured matrices. Ask me later about that because so people have, obviously people in Rust have also faced multiple dispatch as a generic problem. It's been very challenging to find ways to talk about it that maps to what we expect from JuliaLand. There's a version of it that might work via like overloading on certain tuple types, but you look at the code and you're like, all right, I don't even understand this macro. Screw this. I don't have time for it. But yeah. Okay. Biggest takeaway from all of these slides. I talked a lot about if it was borrowed, if it was mutably borrowed, or if it was owned. When you're starting out your Rust journey, do yourself a favor. Just try to know 3 things. Is it the owned version? Is it the borrowed version? Or is it the mutably borrowed? Is it a type T? Is it ampersand T? Is it ampersand mut T? That's going to get you very far in life with Rust. No? You'll see that in Rust, the same type, like the same value, the same bits are going to be stored, like you will be able to talk about it in at least in these 3 different ways. Is it the number? Is it ampersand mut the number? Or is it just a reference to the number, right? Getting that, and then this idea that there's 3 versions of every value that you could express comes up everywhere in Rust. It comes up with iterators. It comes up with functions themselves as closures. It comes up with strings. It comes up everywhere. No?
You can have multi own, like mutably own.
You could,
So you pass that and then you can modify
but
the function.
so it doesn't make sense because you're already the owner.
Yeah,
No?
but I mean, if you pass the function, pass the ownership,
Yeah.
and you can modify that inside the body.
But you already could if you own it,
Ah, okay.
right? You could already, so you could do that. It's just an extra step. People basically don't do it. All right. Also big takeaways. Don't fight the borrow checker at first. Don't do that. Just make life easy. Just clone away, copy away. If your code in Rust is that slow that you need to start figuring out borrow checker, then please, I was gonna say reevaluate your life choices, but no, it's just like if you're writing Rust code, it's already at the speed of C, C++, no? people usually rewrite their Python scripts to be in Rust or Go, and it's like you're already 20x faster or something at least. It's very sage advice to write it out, copying everything first, and then when you really need the performance, start fighting the bar checker if you need to. No? And the way in which you do that is you just add a .clone towards the end of things. And you can also make things clonable with one of our friendly macros. You can slap that macro on top of a struct, no? And then they'll just let you have the .clone on a square object. Does that make sense? I see Scott squinting. Sort of, right? So the way in which it works is the clone method is just boilerplate. You would write out, oh, just get these bits and then put them in this other place. Like it's the thing that you would write by hand. Someone figured out, oh, there's a macro you can use. And so the way in which it works is you'll have to use the hashtag derive on the clone trait, and then that will write out for the square implementation. Oh yeah, you want to get the width field, and then just start from here, mem copy it over there, you're good. Excellent question. I'm waiting for someone to ask that. If you go to systems clone versus copy, one of my colleagues wrote a blog post on some potentially confusing terms of Rust. I'm on Seti, right? And if you go to copy versus clone, these are if you need to duplicate an object you have. The copy lets you have access to the equal sign, no? So that if you have object on the left and then you write let x equals that other object, you can store it also in x. No? It doesn't just bind. If it's copyable, then you'll get you'll get the same bits on the source API and then on the X. No? And this one is somebody put out a really cool blog post recently, but in theory, this trait should only work on primitive bits types that are trivially mem copyable. No? So you can't use copy on a string because then the string could be arbitrarily long. No? So having an implicit copy when you're just using let x equals that would be bad. You would, if you want a deep copy of a string, you'd need to clone. So it performs bit by bit duplication, and it's a marker trait. That's something a bit more advanced, but it lets you know its internals on how the logic of this thing can be. You can use the equals operator to get a copy of it, how it's propagated internally to the compiler. Basically, copy is for bits types. Yeah. Cool.
But since it's a compiled language, like even if you explicitly copy the memory, the compiler could still do some optimizations.
Right. So the question was, because it's a compiled language, if you still copy the bits, you might lose some optimizations. I believe you could lose it on like alignment boundaries, right? So if you happen to know that this struct needs to be aligned on 16-byte boundaries, and then you just you copy it to a location that isn't 16-bit aligned, you'll lose some performance, yes. Also, Rust people tend to start getting into really low-level structures that have self-referential pointers. So if you just copy the pointer that was pointing to somewhere else, then you might need to fix that up too. Yeah. Right. Yeah. Sometimes like integers and floats are copied. Compiler copies these objects automatically. Cloning is very cheap. You could make a type copy. A value is cleaned up when its owner goes out of scope. We call this dropping the value. You can override that value by re-implementing a new version of drop. Oh. Cool. You can specialize. So it would be very, very silly to just assume that one single logic for deallocating memory regions would be valid in Rust. So you're allowed to override it. You could say, oh, when you actually drop something that's wrapped by mutex, it actually has to go through this special process. If you want to drop a file, it actually has to go and wait for the OS to do that first. Or if you're using a TCP stream, then you want to wait a certain amount of time, or a thread, or a database connection, so as to not drop some files towards the end. Cool. So that's the sort of, how are we doing so far? We did the ownership experiment. Yeah. Part of the cheat sheet on strings. So what we just saw some slides on, if I were to go to one of the trainings with Miguel, what's the kind of experience that I would have had? Somebody asked me previously, now that I remember, what would happen if I wanted to do a lot more Rust exercises? We have a whole repo on solved exercises for people that are just eager to solve some Rust stuff with step-by-step exercises. If you're also doing embedded stuff, they have some NRF52 SDKs from Nordic that you can try and work out on some embedded examples. Exercise book, there we go. Source. So yeah, if you want to see, what a FizzBuzz would be in Rust, then we'll have a step-by-step solution and everything, right? Ta-da. Incredibly impressive. If you want to go for a bit more of a challenge, try the connected mailbox exercise, Jamie. That's going to be interesting. Cha-cha-cha. Okay, cool. Yes, Rust, and okay, I get to talk about this. Cool. Rust links, GitHub. They just went through a rewrite. A very new version was released. So it used to have to do all of the setup. The way in which it works now, actually, I might, let's free solo this. Do I have that here? No. See Rustlings, yes. That. Rustlings in it. That already worked. So Rustlings is really cool once you know some Rust. What ends up happening, please? What? Oh, Rustlings run. There we go. So let's say that I have the exercise variables one function and then the if. The if was, it's if two, right? Foobar bas. And then I don't know what there we go. So it's keeping a list of thank you. Okay. So it keeps a list of all of the exercises that you've done along the way. No, it has a certain progression. You can ask for a hint of the current exercise you're on, or go back to the list. It tells you which one you're doing. And then it used to rebuild every single exercise before. They changed around some of the stuff. It has the nice TUI now. It's really, really nice. This takes me like 2 hours to go through it, and I've done it like 6 times now, and I enjoy it more and more every time. It takes a lot more time. It used to take a lot more time because you had to jump a lot through the files, and you had to fiddle with it. It might take a little bit less, but yeah, I highly recommend trying out Rustlings. It's super free. It's and well made. They put a lot of effort into the latest release. Came out like a week ago. If you don't have that at hand, I also recommend exercism.org. Exercism is a site run by volunteers. So you can click on Learn, and then the Rust track here will have a syllabus of different examples that are well known, right? So like write code that detects if you have an anagram. What? Okay. I did over the pandemic for Julia because I have, look, if you, my Julia track has 50 out of, okay, it used to be 58, now it's 67. I gave up on a bunch of them, but at some point I had 100% completion on this. You know? And more important than that, I've also volunteered a couple of people. Scott here has volunteered and helped people get started with it. You get free mentorship. So the coolest thing about it is not that this exists, right? The coolest thing about this is we're going to do something very similar to this in just a second, that you can see the community solutions. So we can go and see, you know, it used to be sort by highest rep user. Colin M. Kane, just the rock star of Julia and of people from Exorcism. So you can see, go and see his code, and so people will star the solution. And so you can submit your own code, but then you go and see how other people solved it. Your starting Rust code will be very C-brained. That's fine. Go and look at how other Rust people solve the same problem in order to learn more idiomatic Rust code. That is going to take some time. No? There's a Julian way to do things. There's a very C way to do it. There's more of a Rust way to do it. No? And just learning it takes time. I found this website incredibly helpful for getting over that. Cool. All right. I also kind of wanted to talk about, I'll mention that this is a big spiel that if I had a beer and you and 30 minutes in the bar later on, I would love to tell you about this whole story. The biggest takeaway that I'm just going to mention now is the error handling story in Rust is super cool. It's built from some very simple fundamental blocks of a result and an option type and generics. However, it makes sense. The context in which that whole type system and infrastructure rose has to do with years and years of really, really crappy situations by C and C++ people. Knowing why they did it, knowing why it hurts, knowing why it doesn't scale in databases, knowing how Rust protects you in those cases is very worthwhile to getting it into your Julia head, because it wasn't evident for me. I didn't come from a systems background. I didn't know about error handling methodologies, how the C, C++ people did it. And a lot of the educational materials, if not basically all of them, just assume, I think you have this context. Here you go. Very few of them tend to actually make an emphasis on, hey, this is why it hurt. This is why this was catastrophic. This is why these are the sort of things that you don't have an intuition for. There's this really, really cool paper that goes into almost 92% of all catastrophic system failures. This was a software-based analysis, are the result of incorrect handling of non-fatal errors explicitly signaled in software. So Rust people care a lot about safety. They see this number and they say, we better do something about this, no? And that's why they make errors unignorable, no? And so in the cheat sheet, I go through a whole example of how this might look like in a C code base, how it looks like in a more modern Rust code base. You have the question mark operator that lets you have a lot of the ergonomics, history. And my final takeaway on that is, or my final bullet points on the ownership system is, all of that context on the ownership system is not something that the Rust people just up and came up with. It's based on decades of what C and C++ people did. They looked at all of the bleeding, at all the self-injuries inflicted, at all the headaches, and then they just said, oh, let's not do that. Like, the way that I like to think about Rust is the C++ programmers, or at least the most well-paid C++ programmers in the world, took like 20, 25 years to get to where they are, right? Like, the level of experience that someone has is like someone who's been decades in the field. Those people still make memory safety issues, being paid millions of dollars. No? Or you can learn Rust in like a month. So my pitch for you is, if you don't want to burn 20 years of your life becoming a C++ arcane wizard, you can just learn Rust, and the compiler will just catch all the errors that those people would not have. The compiler never gets tired, never gets sleepy, never gets drunk, never gets angry with you. It's always running there in the background if you want it to. Huh? So there's only t, ampersand t, and ampersand mut t. Learning a little bit about where the ownership system came from, that none of the concepts that they're introducing are new. They're just the way in which they communicate to the compiler, that it sort of makes sense. Most of your functions, if you start taking ampersand t, you're gonna be grateful for it, at least when you're starting out, for understanding immutability. Unfortunately, I mentioned that everything ties into the ownership system. That also means indexing. Indexing in Julia gets desugared to get index, the array, the number, and then you get the element out of it, no? And then we go through the dispatch system. In Rust, square brackets also desugar to a get index call or something equivalent. But that also means that that function takes ownership over the array. Moral of the story, you can have two different indexing expressions. You can't do a of index I plus a of index I plus 1, because one of them already took ownership of the whole freaking array. How do you get around that? You have to use iterators. If there's one thing you learn from me, please try and learn avoid indexing when doing Rust codes. Try and learn iterators. It will save you so much grief. One of my colleagues, Andres, mentioned this to me, and I couldn't believe how useful it was. Learn to code without using explicit indexing. It's going to make your life as a Julia person so much easier. Okay? Unfortunately, also, operators are secretly functions. So if you use plus equals or double equals, that also hooks into the ownership system. Huh? Okay. Cool. Iterators. There's an example that I go into in the notes. Okay. I think we're due for another break. 5 minutes, and see you back here. Cool. So think about it when we go for coffee. We're going to write a dot product in Julia. Just take a vector of numbers, give me a dot product. A dot product means multiply every element, all paired elements, and then add them up at the end. Does that make sense for everyone? Yeah? Okay, cool. I'm eager to see your examples in a bit. Then we're going to do it in Rust, and then we're going to do it with a bunch of tools that let us have super interactive workflow. What? Not SharePoint. But SharePoint is good.
Yeah, or that stuff. Sorry. I see that is too much.
For your thoughts, for your statistics on that. Basically, to figure out how many people are trained up. It's gonna be just one long video, and then we can start. I saw there was on Slack that the people were expecting the workshop to do screen. Someone complained that took my day off to watch the workshop. Yeah, I think yeah, but the things I don't remember anyone questions not really. But that was not good because someone is also asked like is there a channel for the workshops? Like I mean the workshop or how that they understand that what it means like because if you're in the room then raise your hand or what you want. Oh I don't think it's
All right. We got like an hour left. This is going to be the most hands-on part by far. So, dot products. Who's got it? Dot product implementation. How can you share your code? I don't know. But somebody want to start shouting at me? Let's do function dot. Oh no, no colors. Unforgivable. There we go. Thank you. Okay. Function dot prod 1 x and y, 2 different vectors. All right, go. Someone. What's your implementation?
Sum of map plus what would be x comma y.
Yes. 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 Sum of what?
No, I think you can just pass. Yeah, you can just pass plus there x comma y or comma x comma y.
Okay, cool. And then dot prod 1, and then actually let's call these x's, and then rand of 1 through let's do 1 for I in 1 through 100, 1,000. Let's do that. That one. Let's do 2.
Yes,
What?
it should be times, not plus.
Oh, got it. Okay, cool. And then obviously we got our B of dot prod of x's, y's. Bam. All right. Who's got a better one? Who can think of another one? No? Okay. Yeah, let's do the silly one. Function dot the one we would have always written. And let's do the crappy, the super not nice version of it. For I in 1 through length of x's, and then if, oh my god, I love my life. If x's I is unequal to y's that, then res that, and res. Wait, what did I do? Dot product. No, that's not dot product. Oh, sorry, I got ahead of myself. Yes, because it's basically the same algorithm. No, sorry. That. Like that. There we go. I'll show you in a second how it's basically the same algorithm. Okay, does that look correct? Okay, cool. Dot product 2. Cool, that's a bit better. 17 bytes instead of 8,000 bytes. Okay. We've got another one. Yeah. All right, I don't care about that now, but sure. I'm only gonna feed integers for now.
Iterating with each index because I'm not sure about the length there.
Yeah, or I can even do something like x, y in zip x's, y's. I think that's better.
Does it always give you inbounds?
I think we'll see. All right. Ooh, 90.some bytes, 500 seems to be a bit worse. And lastly, my favorite version, dot prod 4, x's, y's, map reduce. What? That's exactly what I meant. $8,000, unforgivable. Let's do an init equals. Okay. All right. That's my favorite version of it. What did I just demo? We came up with 3 or 4 ideas. We tried to implement them. We benchmarked it. All right. Who wants to try that in Rust now? My takeaway is we are used to running into Julia people or an advisor coming in or a colleague coming in saying, oh, actually, what if we just did, what if you just changed this line? What is it going to be faster? This is probably faster, right? And then in Julia, doing that is going to be fun. Not doing it in Julia is going to be painful. As a self-professed Julia REPL stan, right? I think I have to try and teach people what this would look like in Rust. No? Here's my breakdown of as interactive of a developer session as I could make in Rust. No? And I have my small cheat sheet here. My cheat sheet is, oh, not you. Oh, that's because that's the wrong window. There we go. My cheat sheet is the one on Devflow. First of all, try the Rust Playground. Where did it go? Where is my what? Oh, there we go. So Rust Playground. There we go. So the top 100 most popular crates are included in the Rust Playground, no? And so if you go fn main, and then I'll do let x's equals vec, like that, I can actually get a vector of 1,000 with this. Let y's equals vec 2's, and that. Then I can do something like x's dot iter dot yes, then chain, nope, zip dot y's dot iter, and then map. How I'm basically using a zip here, and then a times b, and then dot sum, and then this will be an I32, right? And then I'm just going to print that at the end. Let res equals that. That. Give me just a second. Rust does by default use I32s, yes. And Yoo-hoo! I think I did that right. Cool. So when I want to share Rust snippets with other people, I reach for the Rust Playground first. No? If I wanted to use a crate like, oh, I want to use random numbers, use rand, and then you can type into random numbers, no? Or you can tap into them. That's probably your best bet for trying out a quick Rust snippet. Let's actually do it on our own computers, right? So this is the Devflow, and then, oh wait, I failed to show how the Hamming distance is basically just also MapReduce with that one, no? But X and Y, that. But yeah, that's the same algorithm. Instead of a dot product, it's just the thing you're mapping is an unequals, not a multiplication. Okay, cool. First things first, you do cargo init. I would call it devflow in this case. We installed cargo watch initially, so I'm going to set up my cargo watch. Minus x check, minus x build, minus x run. No, cool. It's running in the background. Then if I do mod devflow, I have error lens installed. I'm not going to show off BQN today. I will define my what's it called? Dot product. It's going to take in an x's, and that's going to be a 222 I32. This is a slice. I can do just a vector. Notice all of the feedback that I'm getting on auto-completing, no? At this moment, cool. Mismatch types. it's saying, hey, you told me that I was supposed to get an integer. You are so far implicitly giving me this. That is called the unit type. That is equivalent to nothing in Julia. No, I think it's technically the bot type, or the singleton element that's part of the bot, bottom. So what else do we want to do now? We'll say that if I have a function, I'm going to want it to pass tests. So I'm going to dot test. So dot product of vec of 1, 2, 3 and vec of 1, 2, 3. That is going to be, what's the answer there? I'm going to make it easier in just a second, but let res equals, whoa. So 1 and 1, and then 2 and 2, and then assert res is equal to, I believe it's 6. Cool. Mismatch types. Okay. If I just place this, we saw our friend the to do earlier to get Rust to shut up. Cool. Oh. So this macro is going to habilitate this function to be compiled as a unit test. The thing that I want to show you now is that not only Rust Analyzer will let me just run this test individually. So obviously, if I have 1 being returned, that's going to pass the type check. But if I click it here, that would be equivalent to the item test runner. Test item runner for the people that are up to date with our Julia VS Code. No, it's pretty sweet. This is not letting me pass the vibe check because I'm not very interested in you right now. Please let me go. Oh, wow. Some. Okay. Ah. Ah, excuse me. So if I click on run the test again, it's going to say that it failed. Ah, sorry. So I can start writing my function. I can add a small test. Ah, not the best moment for it. The sneeze attack. I can do -x test and then -x run. So I'll have this test be running continuously in the background, no, until I get it right. What else is nice to know here? Another really good point of interactivity here is that, let's show off Clippy. Yes. If I do cargo Clippy, which I will argue is almost as close as we can get to a Aqua .jl. It's not as close, but rather Clippy is a set of lints that will be run against your code base, and it will tell you, hey, you're doing something that we know is kind of BS and or a bad practice. Stop doing that. It's based on the Microsoft Clippy, that thing, mascot. Yeah, the same one. They don't ask about the copyright. But yeah, this function, or I showed you this. I remember when I told you that if you ever use this syntax for calling the vec macro, Rust people would throw their shoe at you. It's so much so that it's like part of Clippy, and it says, oh, you can use array directly. Stop, or rather, it's going to suggest a square bracket syntax. So you can actually also use cargo Clippy -- fix, and then it's going to also say that I need to allow dirty. Yeah. So that when Clippy has a set of standardized lints that will always be run against your code base. when you call cargo clippy. Otherwise, it's not run for you. But then if it detects any of those easily replaceable patterns with the cargo clippy fix allow dirty, it's just going to clean that up for you. I would have died to have that in the Julia user base of, or Julia code base of 5,000 lines. So I've had so many hours of my life wasted because someone had a bunch of random Julia functions that weren't called by anyone and I didn't know, or functions that were stale, or files that weren't included, or just dead code that my IDE did not let me know I didn't have to worry about anymore. And so this is another place where you can just be like, oh, this thing exists. It can just make you not worry about more things, let you worry about less things. And I really, really liked it. Huh? That one did modify my files because I explicitly said cargo clippy -- fix. And then if it, so for example, if I screwed up something and I don't know what I can screw up now. No, I'd have the RAM. But if I can have a clippy say, hey, this is something that I can trivially fix, then it'll do the detection pass first, and then just with cargo clippy, and then you can say -- fix for that to be fixed in place. You can also customize the lints. You can say, hey, when you're using this object, you're never allowed to call this constructor. Like, we know it's allowed, only Greg knows how to call it. Let's just ban everybody else in the code base from using that, stop using it. And so you can customize the set of lints that can be called on it. Huh? Also super interesting, super good thing about running your Rust code. If I have it unformatted and I save it, and I call the format on it, save without format, format document. There we go. You can also set an option where it just saves on or formats on save, and it happens every time you save. I really enjoy when that happens. Sorry? Oh, yeah. I've learned to only turn it on my local projects, because whenever I get other people's projects, especially with numerical code, like I was editing a code where we had to do like this, it was like a differential equation, and someone had like a big matrix of coefficients, and then sometimes you like try to like add up the spacing so it like kind of makes sense, and then you can opt out with the, I think it's what is it, clippy, like do not format or some macro like that, and then I didn't put it, and so it wrecked like 1,000 lines of matrix coefficients, and it was very, very unfortunate because I committed it first and then I had to fight Git and I just cried. Right, so that's something else that can happen. Question?
Yeah, I know you probably already went through it, but how did you get the one test option?
Oh, I configure it as a test. This is just standard part of Rust Analyzer. Yeah, the test item runner.jl is just part of Rust Analyzer in Rust. Right? Cool. Yeah.
You know, like in Julia, generally the library structure is the source folder and that folder. If it's the Rust, you put the test generally next to the function, it's compiled.
Excellent question. Yes, people do tend to use a test folder. I'm going to talk about if you include tests here, anytime that you modify this file, the tests get recompiled into the test binary. They never take a part of the runtime binary, no? But they do end up taking recompilation time if they're part of the same file, which is why they end up being in their own folder. Okay? Yeah. But just when when we're doing scripts like this, starting out with a test just below it and knowing that you can just click it to run it, very, very useful, no? Cool. Aqua, Julia formatter. All right, installing divan. So now we're going to do cargo binstall divan. Oh no. Cargo install divan or cargo add divan. Okay, that's another way that you can add dependencies in Rust. If you're within a project space, you can do cargo add X, and then you can do I think cargo status, no, cargo list. So there's a bunch of utilities that have grown around cargo and cargo tooling, and they're usually called cargo dash something, no? The one that I have installed, I think, is cargo show ASM. Yeah. I'll show how that works in just a little bit. But the reason why I want to show divan is because I think it is as close as an experience as you can get to benchmarking your functions in Julia with the least amount of fuss from Rust. So how it works is you add divan to your dependencies, then you slap this macro in front of your function, you put divan in main, and then no matter where this is defined, when you run cargo bench, then you can just benchmark and you'll get that result afterwards. No, I found there's another very well-known framework called Criterion, which is very useful for doing like more fine-grained stuff. If you're doing like the hacky version of I just want this up and running and I just want to know how long this took and have some statistical tests, divan is my choice for getting that working. So let's get that working now. Yes. If you want to do cargo run, this by default runs in debug mode. It isn't optimized. If you do cargo run -- release, that's doing the -03 optimization and then running your binary. There's been a non-zero number of people that write their benchmarks against Rust, and then their first comment is someone saying, hey, did you add -- release? It's completely equivalent to people saying, did you run the function twice in Julia? And yet, people keep posting benchmarking articles about it. I keep saying there's a lot of funny coincidences. But yeah. Right. Let's do divan.
Told me that the workshop actually ends at 4:30, and also we have a final sausage dinner, and also to inform that at 5 or 5:30 there should be a storm. So if you want to go to hotel or their home,
okay. Thank you. All right, so the dot product was I had my x's, I built an iterator, then I zip that with the y's.iterator. And then they like the syntax where you like indent once, no? And then you keep on writing the iterator there. Okay, and now if I go to my main function and then I do divan main, but see, I'm getting like almost immediate response from my IDE jumping around and doing all these things. Then I can do divan bench. Yeah, divan bench, I think that's it. Expected an item. Yeah, thank you. Ooh, expected args divan, or I think it's just bench. Yeah. Divan bench args equals blah blah blah. So I don't want to do that. For function registration, yeah, that's what they call it. So it's just bench should do it. So this is the part where the error that's just there is not useful enough for me to get enough context. So I'll just do cargo check. Args option containing that, and then this tip needs to go away. If I just write an underscore there, oh, no, underscore sometimes lets you get away from some errors like that. Expect the args containing that. All right, I'm gonna get rid of that and just put it in the main function.
We don't need to import divan anymore.
Yeah. Use divan. All right, cargo check. Shoot. What? I thought I had my. Oh, yeah, divan black box, divan main, divan bench, or black box.
My kernel is a bencher. If you want to provide your pre-instantiated inputs with like flats, then it's first this little bencher.
All right, I'm.
Flat is bencher.
All right. All right. This is not as important for me now. I couldn't get it to work. That's fine. But I did want to try and show cargo ASM. So cargo ASM is what you would use if you want to do code underscore native. There's some shenanigans you have to deal with. Oh, okay. Cargo ASM, cool. And so if once you do that, you have to specify which function it is. There we go. And so there's your assembly. No? The other thing that you can do, I wasn't kidding about this. Just where's my Rust playground? There we go. The Rust playground actually has a, let's build it on release. Let's do it on stable, beta, or the nightly channels. And then you can actually use the tool to get out the, oh, no, where'd it go? There we go. Show me the LLVM-IR. So sometimes getting the LLVM-IR for your functions or the assembly is just easier if you just go to the playground, which is incredibly unintuitive for a Rust for a Julia person not to have that like within your fingertips. That says 20 minutes. Okay, cool. What's up?
I have a question with Divan. Within the benchmarking method, are you able to more or less leave Divan within your package, or when you actually push the release, you have
Right.
to remove all your code?
So I don't have time for it, but you can set up dev dependencies in Rust, right? Or like conditional dependencies. And so you can compile your crate such that if people don't add a certain flag on the command line, they won't pull in that dependency. In fact, I think I have one for a package that I did recently. Let me pull it up, which is staged filter, z stage sg, cool, bat cargo.toml, cool. Can you see that code? Sure. So dev dependency is divan, and also a dependency of mine is rayon, but I flag it as optional. So unless you pull in my crate with the rayon dependency explicitly set on, then you won't pay the penalty of compiling the rayon dependency. No? So there's a lot of knobs for how to not include all of those dependencies.
Okay, so you have like two test runners where it's like one does a like maybe performance test runner, and another does the
Yeah. Yep. Okay, last thing that I want to show here. You know how you have in Julia the what is it? Timer using Mackie. What's the name of the time imports? Yeah, time imports, right? Yeah, using, I'll use my REPL because I'm not doing that for Mackie. But like this will just show you, oh, that's like the breakdown of all those times. Something very similar exists in Rust because they also heard from timings. So this will actually go and put that into this .html file. What? There we go. So this crate is not that interesting, but scale, please. Okay, maybe if I pull out the other one, cargo build timings. Da, da, da. Okay, also not interesting. Let's go to one of my work ones. Oh my God, no, please. Cargo clean. Okay, cool. Now it's good. Now it's rebuilding. Okay, this is gonna take some time. No, It's not incredibly hard, but it did it. So I get these this plot where. Okay, let me show you. All of these. Let's try and zoom in. All of these are dependencies of my crate, and so this is showing me the time that it's spent compiling the crate and the time that it can spend doing it in parallel, right? So the purple slices are where I believe it's sent off to LVM for code gen. Before that, it's in blue. So if you don't know, the way that the compilation model works in both Julia and Rust is we do a crap ton of analysis, we produce LVMIR, and then the LVMIR gets optimized into assembly by LVM. No, it's just, there's way more extra steps on both, not important for this discussion. But the point is, you analyze, you get LVMIR, and then you shove it off to LVM, and then you get back the assembly. So obviously, or not obviously, but rather, you don't get the benefits of the LVM, or you can only start compiling certain crates until your dependencies have been compiled. And sometimes you don't need the entire dependency to be compiled, you just need certain metadata to be generated. So this is showing you the critical path through your compilation process and how long each one took. No? In some cases, obviously, having this sort of tool telling you, hey, your Julia process took this long, it was waiting on Makia to compile until this point, or for pre-compilation, obviously. No? Then it would be, we don't have the granularity to see what specifically we're waiting on. We have certain tools like, oh, you had invalidations here, you had recompilations there, you had GC runs, but it's not like we have a tool that lets us say like, oh, this is the thing that's holding up the critical path, right? Because even if I had more dependencies that were like, I could take longer in one of those other crates towards the top, no? But because they're far away from the critical path, then it doesn't really matter. And then this will give you some of the breakdown. Once again, this was a demo of the cool things that Rust tooling has built for yeah, that we can steal. Okay. Other questions? Two. Install divan. What?
Maybe in linear algebra, how would you represent matrices and any extra text calls? Linear algebra primitives like arrays.
I don't know how I would do that, but I know who I would ask, and it's the fair crate. So this is like the Rust attempt at, so let me show their webpage. If you go to Rust people and you say, hey, you're fast, you have linear algebra, right? And they say, yeah, we do. And then you ask them like, oh, what do you have? And they say, we have dense matrices. And you're like, yeah, and they're like, and sparse. And they're like, we have matrices. And you're like, what do you mean? No, so it's very So I'm not kidding when I say like people come to me now for like Rust advice because like I know some Rust and they come from Julia and they're like, hey, like where's a Julia Slack where I can just ask the optimization people or the graphs people or the the statistics people all in the same place? And I'm like, there's not. I'm sorry. They they just don't have that. They attracted all the people that love to build the colorful TUIs and nice tools, but they don't have the people. They haven't nerd sniped the linear algebra people or the applied scientists. So I don't know how to communicate like there's more traffic in like a single Julia channel with regards to like math C papers than there is in like almost all the other Rust Discord channels that I know put together. It's so one Julia channel versus almost all the other Rust community that I know, you get more traffic on your nerdy ideas there, like than you would. Not that you don't get nerdy ideas in Rust, like people are sharing papers. It's just they're not sharing papers about your screwed up version of statistics that you really want to implement and you want to like publish somewhere. No, o sea, and you really need those banded matrices for whatever. No, o sea, and obviously, what I've seen is that archipelagos or hero groups of Rust developers sort of like come together and are like, oh, we're going to now do this one cool thing. And it's well done and it's cool. But it's not the same as like, hey, we have a multi-dimensional interface for arrays in Julia that a lot of people can share their work on. It's like, no, we went and built our shit. And if it plays nice with that, that's cool. That's not the same as, oh, I want to have my arrays and then just like hit it with GPU arrays or hit it with like some other stuff from linear algebra. So there's a sort of a disconnect from like, oh, if I'm staying within the Rust strengths, it's going to be a very fun time. I'm only using dense matrices. I like my stuff can work out of the box. The moment that you get slightly more exotic, it's like I hope you find someone that built a wrapper for the screwed up lab pack that you need. Otherwise, you're just it's not going to be fun. So I happen to know the developer of Fair. They're very capable. They're really good at like doing the SIMD stuff. But it's just like you can't write a linear algebra ecosystem by yourself, not to the level that Julia people expect, which is fine. They didn't go for that as a language, but now if you want that alternative, it's different.
Yeah, this is like when you mentioned like there's full linear algebra example about multi-structure or something like that.
No, no, no. That example does not exist yet, but thanks. What does exist is people have written the Rust version of NumPy. I think it's called N algebra and or ND array. And so it was very much, there's one of them that was written very much as a NumPy replacement in Rust, which is great until you realize they also have the intermediate array problem that NumPy has. So they still get killed on all the intermediate allocations. So if you do A plus B plus C in NumPy arrays, your B plus C is going to allocate an intermediate array, and then that plus the A, you're still going to be hit by that. And they did that explicitly in order to be like, was like not intellectually compatible, but like semantically compatible with the what NumPy with NumPy semantics. Huh? Yeah. No, not that I know. Some people interested in scientific computing in Rust have wanted to write something like broadcasty and are familiar with Julia. But once again, it's like 5 or 6 people that kind of want to get one thing off the ground and have a very specific application that they want to write for. Not we're a group of people that want to share an interface for an entire ecosystem of linear algebra and like have it in like interconnect between all these different people.
My question was rather about the non-NumPy like
Oh,
the broadcast the same way.
I don't know, but yeah. Sorry?
Like would you just use the Julia libraries for differential equations in algebra in Rust instead of reinventing the wheel? You want to
Yeah, I like there's a package for calling Julia from Rust. No, this is the best that we can offer right now. So this lets you access arbitrary Julia modules and their content, call Julia functions and clippers that take keyword arguments. this is what you would want, I think. Question in the back? Yeah. So the question was, can I change this to work on slices? So a vector is always allocated on the heap. A slice is not necessarily allocated on the heap. There we go. And so, what? It can be, no? So you're generic over the collection type in a sense. You're only passing that you have a collection and a length, not a vec necessarily stores its data on the heap. That's one of the things that you start to care about when you go into Rust, no? Otherwise, yeah, don't worry about it. So I did that, and then it should still work with a vector. No size for values. This is a slice. This is a slice. Argument to this function correct. Oh, I forgot. I always get this wrong. So please doesn't have a size known at compile time. I just saved it. Okay, thank you. And then if I run this, right? So the leap of faith would be if I wanted to turn this into a generic collection, right? So that is a very screwed up looking syntax for I want to have a generic 1D vector in Rust. The way that I tried, so thanks for that question because this bit me so hard. I'm willing to take time out of this presentation to like talk about it. So if I have an array type in Rust, it looks like this. No? Or, yeah, so this let x equals, and the type of it is I32 for that. After the x comes the type annotation. That is saying I have 4 numbers on the stack. That is the type. No? Remember, the things that go after the semicolon in Rust are the type. That's a type annotation. And it's telling you that as part of the type, it has a number, and that number is 4. You know the length of that. You can communicate that to the compiler. However, if you do, oh, please, what? Nope. Thank you. Let y equals I32. Then you can do something like vec 10. Mark, that type, does it have a number after the I32? It does not. So it's not communicating the length of the size of the type to the compiler. What you need to communicate the size is actually a reference, because references carry length. They're fat pointers. Okay? So somehow it's either with an explicit number or it's with a reference, so you pay some runtime cost. But because there is no colon 4 afterwards, you don't know the size of it at compile. Okay? The name for the type on the top is an array, and it is not the same array that we have in Julia. No? The name for the type on the bottom is called a slice, and it's not the slice that we have in Julia. I know it's confusing. It looked horrible. I'm used to it now. I don't know how you could change it, but once you start writing the generic slice manipulation code, it's not that bad. What's up?
If you write another function that calls out product,
Yeah, you could. Yeah, I'd have to do like unsafe access, right? So I just like do the offset of and then get that. Yes. Yes, you could do that. That's not fun, but it's doable. No? Ah, so that's actually the last topic that we're covering, which is right in the live code demo, FFI. So someone asked at the beginning, what's a foreign function interface? That's interfacing Rust with foreign functions or interfacing foreign code with Rust functions. The application binary interface is if I give you a binary blob, what are the invariants that you can expect from that to uphold? So it has to do with, do I know that you didn't clobber certain registers? Do I know that you passed certain arguments and only these registers? Do I know that these arguments were saved to the stack afterwards? It's a very bare bones. When I want to translate this into assembly, what are the guarantees that I have when I am trying to call functions that you defined yourself? Spoiler alert, it varies between Linux, Mac, and Windows, and everyone can do their own stuff. Sometimes even compilers. I will give you a really, really cool recommendation if you happen to be writing this sorts of stuff. Somebody in Rust came up with ABI Cafe. Oh, please. I trust a GitHub page. Oh my God. Okay. Click here to go to directly. No. ABI Cafe. For people that have done like conformance of ABIs across like different compilers, this will be basically magic. If you've never heard of this before, take my word for it. It's magic. No. So ABI Cafe automates testing that two languages / compilers agree on their ABIs. It does happen that if you have the same clang on different machines trying to compile the same code and share a binary, that can differ because of platform jank, or from clang 14 to 15, something changed and you didn't know, or GCC should have respected that interface, but they clobbered the register, or God knows what kind of horrible nightmares scenarios people can come up with. So what ends up happening is that this crate will help you automate a lot of those test cases and just fuzz whatever you're trying to send through your FFI. So it creates a header file describing an interface. It generates source code for a user and implementation of that interface, builds and runs the resulting program, and checks that both sides solve the same values. If they agree, it's great. If they don't, it sucks. Yeah, this got a huge upgrade within the last week, I remember. Okay. What I did want to mention that you were talking about, Mark, is that you can add a @reprc on top of your structs in Rust, no? And so that will help you have the C version of the layout. And you can also have, you'll have to tell the linker that when you want to expose a function to respect the C ABI, you'll do the extern C in front of the function with a hashtag no mangle, no? Those are all a crap load of shenanigans that you have to start dealing with when you want to do that. However, once that is compiled, you can just do the @C call from Julia, magic adder new, and then call that example. No, if you feed an U32 that is C compatible, then you'll be able to get that back. That's basically it. This is what it would have looked like in C. No? Save yourself some of the headache if possible. There's different options for what you can actually compile out from your Rust crate. There's like different objects that can be spit out. You have to add which one you actually want to emit, no? in your cargo.toml. And if you want to use C from Rust, that's not relevant to us. Rust has a crap ton of C integration facilities. So you'll have a C underscore uint, a U8, a C-stir, or a pointer to a const C car, and then a box T. The last thing that I want to show is that you have a macro on line 8, right, for feeding strings directly to C. It will just take that string and add the null terminated byte at the end. And yeah, if you want to generate C headers from Rust, there's a crate called cbindgen. So it will look at all of the functions that you named extern C, and then it will generate the headers for you. If you want to get Rust source from C headers, there's another one called bindgen. This one was the first one that was created, obviously, because they wanted to bring everything into Rust. But the thing that we could want from Julia is we could have something that takes those C headers and automatically imports them into C calls. And that, in theory, could be a application of Diplomat. Diplomat is exactly that. It's an experimental Rust tool for generating FFI definitions, allowing many other languages to call Rust code. With Diplomat, you can simply define Rust APIs to be exposed over FFI and get high-level C, C++, and JavaScript bindings automatically, right? So you would just point it at your Rust crate, and then you could get Julia bindings out of it. You could. That would be more from the Julia side, right? Yes. Yeah, that would be. That's a good hackathon project. Yeah. Okay. All right. Well, hopefully I didn't bore everyone to death. And let me try and take a picture. There's a storm or something? Yeah.
I think I got the divan maybe to work. It's complaining with the times and there.
Copy is not satisfied.
Sorry, I deactivated the track.
You said it was too broad.
Yeah, I didn't find out how to give it two arguments.
And now, okay, not satisfied. It might be because you use the tuple. Yeah, they don't overload tuples to have like special functions.
Two arguments.
I think you can just define. It's one of my problems with divan. It was like a couple of happy paths, and then the rest is not as happy. But so when I said it's as close to the BenchmarkTools experience as I can, it's still
Okay, I tried Googling it, but I didn't find any example that used more than one parameter. So I figured I could just cram it together into a tuple.
Yes.
But it should be able to. Trigger on copy is not satisfying. How about we do